Hello. So this is for your assignment on using Excel for regression and for projections. And I'm going to show you how to download the data and then the basic operations that you need to go along with it. You'll need to download your own data, do the functions yourself, create the chart, and then be able to come up with some conclusions when you upload the file. So first, let's start off with how do you get the data. You need to download 3 sets of data according to this assignment. You need to download the S&P 500 closing data, and then you need to download the data more or less for stocks that correspond to your first name and your last name, and I'll show you what I mean by that. There's not anything specific, so in other words, my name is Stephen Jones. I don't have to find a stock named Stephen and a stock named Jones. I don't expect that to be there, but my name would suggest stocks, and I'll show you how to get those. So first thing that you need to do is to go to, as you see the URL up there, finance.yahoo.com. That is the website that you're going to download all of this data at. It's easy, it's free, you don't have to have special accounts or anything like that. Then once you get to that screen, you'll notice there's a search for news, symbols, or companies. If you'll click in there and just start in there, the first data that you need to do is to choose the HAT GSPC. Okay, that's the S&P 500. If you can't remember that, if you do the S and P 500, you're going to have a little bit of a problem because it's not going to come up exactly like you want it to look like. GSPC is going to get you there, however. So you got to remember those 4 letters, GSPC. You do not want the Goldman Sachs Capital Growth Index, okay, not the GSPCX. You want the HAT or caret GSPC. That's the S&P 500 index. It will take you here. You need to click on the link for historical data. You can see that tab on that page. Click for historical data, and then it automatically comes up with a frequency of daily stock prices, and they're historical prices, daily stock prices for the last year. We do want the last year, but we don't want daily. That's way too many observations. We're just going to use weekly. So you'll do weekly historical prices last year, October 15th to October 15th, and then apply. Now, it is possible that you will not have data for each and every one of those weeks for your stocks that you're choosing. So you have to be careful which data that you download. If you miss a week, it's not that big a deal. But if you're missing half the weeks or a tenth of the weeks, you really need to choose a different stock. So you'll notice when I went to apply that it now has October 15th, 8th, 1st, 20, blah, 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 all the way back. And it goes from this last today, which is null. It's not at the actual close yet today. But that doesn't matter. It doesn't matter, if it's the actual data or not. But you'll notice it goes back all the way down to it shows blanks for October 9th, and really the data starts at October 16th. That's fine. So you then click on download data. You see this here, click on download data. I'm going to go ahead and open it up. If you need to download it and save it as a file, you can do that. You'll notice that it comes down as caret gspc.csv. It opens as a comma separated values file. Go ahead and you can open it up. Don't worry about the data just yet. Now I'm going to put in my first name, and I'm going to go little by little. So S. Well, I've got Sprint right here as a possibility, so I could use that. If I continue to type my name, I'm not getting any better ones. U.S. Steel is a possibility, but I particularly like others better. I'm going to go, I don't see any others that I really like better. I'm going to go back and go to Sprint and just select that. Okay. Now, it downloads that data. You might not have seen the shift, but it downloads that data. And so you put that in here. Again, look for October 15th to October 15th, historical prices weekly. But you'll notice over here, these are not the weekly prices. These are the daily prices. So when it gives you the historical prices for, in this case, Sprint, it's not doing the weeklies. It's reverted back to daily. So you have to click Apply so that you are sure to get that weekly data like we had before. Download this. Then I'm going to go with my last name, J-O. Well, I could go with the Dow Jones Industrial, but that wouldn't be correct either. That's an index. Johnson & Johnson's a possibility. Let me take a look and see if there's a better option out there. Oh, I don't see a whole lot. There's Jones Energy. I don't know them that well, however, so I'm going to stop with Johnson & Johnson and make that selection. Now, for you, the same way. I'm not telling you which stocks to choose. I want you to go through, download the data that seems to fit the requirements of this assignment based on your first name and your last name. And if you have to play around with it a little bit to find something that's useful, that's fine. You just need to be able to download your 52 weeks worth of data over the last year, because we're going to use that for doing our calculation. So again, we're going to have to do the reapply over here because I'm getting the daily data there. So that's the year, historical prices, weekly, apply. Now you'll see I'm back to weekly data there. Download it. And no, you do not have to start yours on October 15th. You just need to go back and do weekly data based on which weeks, based on the day that you are actually downloading this data. So if it's a couple of days later than this, that's fine. I don't care. You're just downloading weekly data. Click Open, and there we go. Okay, so we are done now with the downloading of the data. You'll notice this is Johnson & Johnson. Now here's what I need to do. I need to have pieces of data in my Excel spreadsheet, and I'm calling it this one right here, Excel for Regression. I need to download specific data. This is the data itself that I have downloaded already. But you will notice that if I open this up a little bit, this is the date, and I've got the dates in there, and these are nulls because on each one of these we didn't get anything for the week of October 9th. So we downloaded these dates. I don't want the open, the high, the low, or the close. I want, or the adjusted close or volume. I do want the close. So I have downloaded the close data all the way through. And that's the information that I've put in for the S&P 500, Sprint, and Johnson & Johnson. And you'll notice that when it downloads the data, while over in over here, when we downloaded the data, you'll notice it starts with October 15th and counts backward. But when it opens it up as a spreadsheet, it actually pulls it down from the earliest date down to the latest date. Okay, so we will pull that close data across in each one of these and open that up. I'm going to close those off because I've already downloaded the data. And we're going to start with this information right here. So this is the actual data, closing stock data for each of those weeks that we've been looking at, the last 15 weeks, for Sprint, for Johnson & Johnson, and this is the S&P 500. I want you to use the stock tickers at the top of each of your columns so that that is what you're using to identify which column of data that you're actually using. Okay, so don't put the name of the stock up there or whatever because it may be fairly long. Just use the short ticker symbol for it. Now, you'll notice this is in date format here, and each of these is in number format. I've changed these over here to number format. It's got 2 decimal points. Even though the original data had more decimal points than that, I'm just having it show the 2 decimal points. It doesn't matter. You still are going to keep the same information. It's just only going to show 2 data points. Now, the next thing that you need to do is to do regressions, where we're going to regress the Sprint and the S&P 500 to see about using the Sprint data to essentially to explain the variance in the S&P 500. So we will go back to, if you've watched my video already on Excel with regression, you know what we're getting about what we're getting ready to do here. We're going to go to the Data tab. I have already downloaded the data analysis and solver functions here. If you need to download these because your Excel does not show this, again, go back to that other video to see how to download the data analysis tools. Click on data analysis. We're going to use regression. Click on OK. Now, I'm going to delete this information here real quick. So, you would normally have it come up where you wouldn't have any information in here, but it would show up like this. So, we are going to have it go to do an output here. I want to have ready access to the regression information. Then I want it to understand I'm going to use labels. I'm going to use these labels at the top here when we're doing our regression equations. My Y is going to be the S&P 500. So I've just highlighted that column of data. And my X to start off with is going to be the Sprint data. So by using the columns here with labels, I will have it put the S&P 500 and the Sprint labels correctly into my regression output, be able to see what information that is. Now, I don't care about any of those or probability plots or anything like that. What I want is an output right here. I want the S&P 500 for my Y. I want Sprint for my X, and the labels on there. And we click on it, and there you go. Now here's one thing I want you to do. I want you to identify which X you're using. So in this case, I have added the S to summary output so that I know that this regression information is about S. Now I could look down here and see that S, but by putting it up here, it makes it doubly clear which one that is. Now, when you look at the regression information, I'm going to normalize the size of those columns here. Remember, as you were looking at this, go back into your book, it shows you this as well. The R square here tells you essentially the variance, amount of variance that this equation explains using sprint, and how much of the S&P 500 the sprint data explains within S&P 500. Well, it can tell you a whole little bit. There's not very much explanation in there. There's not even a percentage at all. Notice that your significance, this is your F, and if you were to look it up in a table, you'll see that the significance is very unimportant to you. You want the smallest level of number here that's possible, and what you basically are saying is, since it's not a 0.05 or less, that we cannot reject the null hypothesis. In other words, that it makes no difference to it. That's fine. I don't care whether or not your regression comes out statistically significant or not. That's not the point of this exercise. The point of this exercise is you being able to demonstrate that you understand how to use Excel to do regression here. The other points of data that are important, so that's the amount of variance explained, that is the significance, which is not significant, that's the intercept, and that is the slope for S on this one. Okay, next we're going to do the next regression analysis as well. Click back on data analysis. We're still doing regression. Now we're going to do regression, same Y, we're not changing Y. We are going to change and do Johnson & Johnson. Everything else is the same except I need a new output area. If I don't click on that new output, I'm going to overwrite everything that's in here, and I don't want to do that. Click on here, and now we go down and identify this as Johnson & Johnson. Now you'll notice again, now this has a much higher level of explanation, but we were starting out here with less than 0.5% of the variance being explained. In this situation, almost 5% of the variance is explained. But even though that is more, that's still not very much being explained. You actually, tossing a coin in the air, gets you at least 50-50, so you don't have that much explained by this situation. And notice here, your significance is much lower than the one for sprint, so this is a better predictor. Johnson & Johnson is a better predictor than you find with sprint, but it's still not significant statistically, because we're looking for, at the very least, 0.10. 0.05 would be better, but 0.10 at the very least. So that is important, that is important, and here's your intercept and the slope for Johnson & Johnson. Finally, we're going to do the multiple regression, and that is where we put both of the X values in there. We're going to maintain the S&P 500 as our Y. Now for X, we simply highlight both columns. See, both columns are highlighted here and being used. So both column C and column D, their data that's in there, we have the same labels being used, so S and J are both going to be used. I need to change where my output is going to be. It's going to be there. And then click on this. So here's this data, and here's what we get. So now it becomes a better explanatory variable. Notice this was almost 5% being explained, and this one happens to be over 5% being explained, but you're using two variables, so you actually are excuse me, you're actually not doing a very good job of explaining, even though it looks like you're doing better, you're not. Notice the significance level has gone down. That is because you're trying to use two variables in here, and the sprint does not add enough explanatory information to be able to make this multiple regression equation significant. You still have an intercept, and now you have two slopes, and those are both very different than the slopes that you had before. The Johnson & Johnson is relatively similar, but you had a slope of about 10.8 on the single regression for sprint, and now you actually have it negative. And you'll see what effect that has in just a little bit. So, take a look. That is what your outputs are going to look like. If you wanted to highlight, you don't need to, but if you wanted to highlight the critical information that you were going to look at, you could highlight those areas. I'm just showing for interest. You can highlight those to help you in the next part if you want to. You don't have to do it for me. I know where to look on your files. Okay, now you need to look at the projections part. In other words, we're going to try to use these outputs to help us see how well the regression equation predicted what the S&P 500 was going to be. So I have copied over here the date column and the S&P 500 column, and then I have three other column headings. Now this is the intercept and B1. This is the intercept and B2. This is the intercept and B1 and B2. Now, why do I have B1 and B2 here? Well, I could, instead of 1, have put S, and I could have here have put J and J, and then here put S and then J and J. Now I could do that. I didn't at first because I wanted to still identify Sprint as the first and Johnson & Johnson as the second, and also because I didn't want to confuse you to make you think that you had to put S and J in there too. So, but I'm going to in this video now so that you can see what it is that I'm doing. So I need to use that first equation that's got sprint and its intercept to try to predict the S&P 500. So I go to, I want to make sure that I hit the right pieces of data there. I start off with a formula, and in Excel, if you use the equals sign, you can start your formula that way. Now I need the intercept, and in this case that's the intercept. Then add to, oops, pardon me, here's an important point. When you click on that intercept, you want to be sure it's that specific cell every time that this calculation is done, because we're going to have 52 calculations to do. You need to hit the F4 key. The reason you hit the F4 key is because you want to identify F18 in this case You want F18 to be the specific cell every time when you go down. Otherwise, it'll take F19, F20, F21, F22, and at a point, it's going to become pointless out there. Now, I'm going to add in the S coefficient or slope times this data here. But again, remember, I need to keep that same S coefficient, S coefficient all the time. So I need to make sure that I put the F4 or put a $ before the F and a $ before the 19 or whatever your cell coordinates come out to be. Okay. Now I need to do the same thing for Johnson & Johnson. So equals. Now I go down here and my intercept is this F4 plus Johnson & Johnson F4 times, pardon me, let's go back. I accidentally hit the wrong button here. We're going to do that. Okay, so here's what you're going to notice. We have a different intercept for this one between these two because we're in different formulations, and we have a different slope for the x variable, and then we're going to have a different here a different cell value as well. But here's what's going to happen is every time that I multiply this times the next cell value and add the intercept, is going to give me a different value here for what the S&P 500 could have looked like. This one's a little trickier because you've got the intercept, and then you're going to be adding in here these two values as well. And so we're going to, it's just a little more complicated of a formula. So equals, you need to go down to the S and JJ and J and J. There's the intercept. Now we're going to, oops, pardon me, very thing that I got to do every time. Okay. Plus, I'll get there. I'll get there. It's easy to forget. Plus, just doing the same thing that I've done before. Okay, here you go. You'll notice now that I have, for each one of these, I've got an intercept, and then I've got a slope times the data point. And in this last one, I've got a slope times data point plus a slope times data point, because we're using both of those to try to predict the S&P 500. Now I just need to copy this down. Now here also, when you copy this down, you'll be able to see if you made any major mistakes. Why? Because I'll start getting freaky data, and it'll be like zeros, or it'll be like the same number down here. Well, that just tells me I made a mistake on my formula. I need to go fix it. And if I need to go fix it, then I can come up here and fix whatever that formula was. But it looks like I got it correct. Okay, here's the last part. I know, it's been 30 minutes, but it's complicated. Here's the last part, though. You need to create a chart of all this information. Now, you can highlight all of that and then go up to charts. And I've got the scatter plot up here is on one of my go-tos, but you can do the same thing just by going to formulas, or is it insert? Insert. There you go. And there it is right there, the scatter plot. And so I want the scatter plot just like that. Now I need to make this bigger so I can actually see what it says. So it's pretty easy for me to take a look and see that all of this right here is where the action is. None of this is. So I can come in and I can, on my data, I want to change my axis options here. I don't need to go down to 0 on the Y over here. So I'm going to go down to, say, 2000. And now you'll take a look. We'll just increase this a little bit so you can see easier. Now take a look and see what's going on. So if my regression equation is correct, if I'm looking at this right, when I look at my chart here, it looks like Johnson & Johnson is just down here. It's relatively following the sprint information as well, and then it's just undershooting it there. And then the multiple regression line, notice coming up like this, shows more variability than either of the other two do, and that reflects, actually, here's what the S&P 500 looked like. This is what it's like. So none of these lines does a very good job of actually showing the variability that's within the S&P 500. And that's kind of what our numbers said too, isn't it? None of them came back with much variation being explained in the S&P 500 up there, because it simply didn't talk to how the data was moving. Okay, then you would save this file. I'm going to save the file. Now I have it as this, but here's how I want you to save it. I want you to save it with your last name and your first name. Okay, and that's what I want you to put into it so I can know whose file it is. So it's your last name and first name. Save it as an XLS or XLSX file, and then upload that file to me through Canvas here. When you do that, I want you to just briefly type out for me the same conclusion that I just drew from here using the chart and using my regressions before, that neither of these, Sprint nor Johnson & Johnson, is a good predictor or explanatory variable for the S&P 500 as a stock index, and would therefore be useless if you were trying to make predictions or forecasts in the future. Now notice here I've taken some of chapter 5 with forecasts and been able to show you that regressions help you out with that. You take care now.